Hey, welcome back. We are going to look at mosaic plots today. It's a different way to represent categorical data. It is new to the AP test. It came back, or it started on last year's test. And this is used when your groups are not the same size. So most of the time we say don't use frequency when you're dealing with groups that are not the same size. And here's where we get to use percents. And we're going to determine based on the larger quantity which one gets to have fatter graph bars. So when the high school that was built in 1969 needed to pick a mascot, the principal decided to let the students and teachers vote between three choices: Rams, Falcons, or Prairie Dogs. He took a random sample, again, important word, random right there, and a random sample of teachers, and the results of the surveys are given in the table below. So we have teachers. 80% of the teachers chose Rams, 10% chose Falcons, and 10% chose Prairie Dogs. And 30% of the students chose Rams, 60 chose Falcons, and 10% chose Prairie Dogs, same as teachers. And we want to create two bar graphs to represent the data using three different colors for the bars. So we've got our teacher bar over here. And for Rams, we had 80%. So I'll go ahead and use the red. Remember, these are bar graphs, so they don't touch each other. And our students chose 30 for Rams. We're going to switch to blue. And the Falcons were 10%, really tiny, and 60% over here. And the last one was the Prairie Dogs. I'm going to use pink, so it's obviously different. And then again, we had 10% and 10%. And when you compare these two graphs, it looks like teachers prefer Rams, students prefer Falcons. Well, we're going to complete what is the stacked bar graph, the segmented bar graph, and we're going to do the teachers. Which would put us at, let's change colors again, 80. 80, come on. Select, there we go. Okay, we're in 80%. Is in red. And then we're going to add blue. We have a little 10% for blue, so that takes us up to 90. And we're going to go to pink, and we have 10% for Prairie Dogs. So that is our teachers. And then we're going to do the same thing for the students. Starting in red, we had 30%. Side by side. Blue. And we had 60, so that takes us all the way up to 90. More like the Leaning Tower of Pisa here. And then the last one in pink is... So when we see them side by side, there's a very big difference between the red and the blue, between the Rams and the Falcons. Well, here's the thing. There's a lot more students on campus than there are teachers. So when we get to number 5, we're going to come back to this and make some adjustments. According to your display, which mascot appears to have the most support? So based on this, it looks like Rams. If you look at these guys and these guys combined, that's more than the blue and the blue. So it appears that the Rams, if you stack the bars for Rams together, For teachers and students, it'd be taller than the bars for the falcons or the prairie dogs. Okay, so let's see if that holds true. If there's anything else we need to know. When they went back and looked at the two groups, there were actually 80 teachers who chose rams, 10 who chose falcons, and 10 who chose prairie dogs. And in the students, they had 150 choose rams, 300 chose falcons, and 50 chose prairie dogs, for a total of 230, 310, and 60. So there's a very big difference in the size of the groups here. So we've always said use percents, use percents, use percents. Well, now, if the groups are drastically different in size and we really want to see if there is some other kind of thing going on, we can do what's called a mosaic graph. We're going to add 4 more bars for the student graph to represent the 4 different, the fact that the teachers or the students group is 5 times, sorry, went too far, 5 times the size of the students. The students are 5 times the teachers. So I have 1 bar here. We're going to come up and we're going to add 4 more for proportion. So I've got 1, 2, 3, 4 more reds. And we're going to do the same thing with the blue. And then finish with the pink. So now we can see a very different story as far as who preferred what and who got to pick the mascot. The falcons now appear to be the preferred mascot. There are more people who chose falcons, 310, than the other mascots, 230 or 60. You can see this in the new graph because you now see the width of the graph. So this allows us to look at combined groups. If we're looking at total population of the campus making a vote and not comparing it from one group to another. So that's the difference in the mosaic graph and the traditional bar graph. Okay, I'm going to get you your learning targets for the next section, and then we will talk about whether or not we're going to do this together or you're going to do it by yourself. Okay. All right, so categorical versus quantitative. These are the learning objectives that you need to know. Categorical versus quantitative. We used to say qualitative and quantitative because categorical variables have some sort of quality, but it was too many Q's and people got confused. So we switched words. So categorical variables take a value that are names or labels. Quantitative variables are numerical and they measure a quantity. You can find an average for a quantitative variable. You can't find an average for a category. Categories are what is describing the individual in the study, and quantities are how much of something is being described. Types of displays that we can use for categorical variables are bar graphs, two kinds. We have side by side and segmented. And then we also have the mosaic, which is width related. It shows the extra proportion of individuals for each corresponding category. And you can use a pie graph as well. We just don't see it very often in AP. And then association. If knowing the value of a variable helps us to predict the value of the other, then the two variables are associated. The mosaic plot is considered a modified bar graph, segmented bar graph. And it is proportional to the size of the groups that you're working with. All right, let's see what we can do here. So I want you to pause the video, and I want you to see if you can do these problems. And then when you're done, you're going to push play and come back and check your work. Okay, the first thing that you want to do when you're working with a mosaic graph and you see a two-way table is to look at your totals. The following table gives the results of a random sample of upper-level students at Rocky Vista University, the Fighting Prairie Dogs, along with a mosaic plot. And on the left-hand side, you have the variable employee status, and on the top, you have grade level, employment status. So currently working, not working, but had a job or have never had a job, and then high school grade level for juniors and seniors. So we had 14 juniors currently working and 30 seniors currently working. And of the juniors, we had 22 that were not working, but they've had a job, and 15 that had never had a job. 40 seniors are not currently working, but have had a job, and 10 have never had a job. And if we add all these up, we get 51 juniors and 80 seniors. So as you can see, that's terrible writing. As you can see, the seniors are a larger class. So in the mosaic plot, red represents never had a job. The light blue is not working, but have had a job in the past. And then the dark blue at the bottom is currently working. Calculate the proportion of juniors that are currently working, not working, but have had a job, and have never had a job. So 3 different classifications. So junior, currently working. There are 14 of them. And there are 51 juniors because it says of juniors. So this is a conditional probability. And that is about 0.27. And then we want juniors that are not working but have had a job. Too many words. And that is 22 out of 51, which is approximately 0.43. And then we are also looking at juniors that have no job and never have had one. And there were 15 out of 51, which was 0.29. And we're going to repeat that process for the seniors. So you have seniors that are currently working. There were 30 out of 80, and that's 0.38. And seniors that are not working but have had a job is 40 out of 80, which is 0.5 or 50%. And seniors that are no jobs, never had one, was 10 out of 80, and that was 0.13%, or 0.13 or 13%. And that's the table, and that's where we got the table. And I want you to write a few sentences summarizing what the display in Part A reveals about the association between the grade level and the job experience for the students in the sample. And you should have come up with something similar to this. It doesn't have to be exactly these words, but there is an association between the employment status and grade level. Knowing whether or not a student is a junior or senior impacts the likelihood of their employment status. For example, seniors are more likely to be currently employed. You can see by the blue shading here than the juniors are, and are more likely to have had a job in the past than juniors as well. Okay, that ends this section. I know the paper says 2-2, but this is something that is supplemental. This is not currently in our textbook, but it is on the AP test.